Welcome back everyone. In today's video we're going to show how to run example 2 of yupi examples gallery, and in example 2 we do a comparison among several tracking algorithms that are all designed to track the position of a moving object in a video. All those algorithms work in different ways. One of them looks for the color of the object, another one looks for the motion, and there are several different principles of which those algorithms are based. But in this example, what we want to show is that regardless the nature of the tracking algorithms you choose, you can obtain very similar results when tracking objects in a video. Of course, the selection of a tracking algorithm should depend on the conditions of the video, because not always you can rely on colors, or sometimes it's better to rely on motion, but it will always depend on the specific situation. But in this example, what we want to do is to compare the results of different algorithms. So if you go through the example in the documentation, you can get a very detailed explanation of this example. So what we are going to do is basically run this example and see the output of the code. So let's go to our local version of the examples, open a terminal, and simply run python example2.py. So first we get a window that asks us to click on the center of color matching to init ROI. So color matching is the name we gave to the tracker that is going to follow this small ant here using the color matching algorithm. So we have to initialize this tracker in one region of the whole image. So let's click over the ant. When we click over the ant, we have this output here of the example saying that the region of interest was initialized, and press any key to continue. So we can continue. Now we get another window asking us to start the region of interest of the frame diff algorithm. So since all algorithms are going to track the same object, we initialize all of them in the center of the ant. Just notice that if you misclicked, you can always click again, and until you don't press a key, it won't it won't consider this starting point for this tracker. So then we hit enter, for instance. Then it asks us to initialize the background subtraction algorithm. We do the same, we initialize it on the ant, and then we initialize the template matching algorithm also in the center of the ant. We hit enter, and finally we initialize the last tracker, that is the optical flow. Now we are seeing the evolution of the tracking process carried out by all the algorithms simultaneously. We can see the consistency of all the algorithms, and we can see that there is at least one of them that is kind of flickering. This is maybe because of the nature of this algorithm. Maybe it's an algorithm that relies on motion, and when the ant is kind of not moving, it may fail. But when you are tracking an object, you should try different of these algorithms and see the results you get with them. And also all these algorithms have some parameters you can tune in order to achieve better results. So here you can see that in the same tracking process you can have multiple trackers gathering the position of an object. Now all the trackers are tracking the same object, but you can track multiple different objects at the same time with different trackers. So let's take a look at the results. Here we can see we have all the trajectories computed by different algorithms, and we can notice that the green one has several spikes on it that we can clearly see as a problem when you're tracking, and that is why it's important to compare different algorithms and choose the one that suits better the situation of the video you're using. But in general terms, we can notice the consistency, at least in general terms, among all the algorithms. And then if we zoom, for instance, to this region, we can notice how most of the algorithms are really consistent. In this case, we can say that all of them except the optical flow one, that it can be tuned also to consider different thresholds, and you can get a better performance even for this video. I really encourage our viewers to try to tune the parameters of of any of these algorithms and see the outcome of the process.